Next, first order reactions. First order reactions. So, what are zero order reactions? Reactions in which does not depends upon the concentration of reactants. Okay? So, reactions which does not depends upon the concentration of the reactants, initial and also final, overall concentration of the reactants. Okay? Then, first order reactions which depends upon the concentration of the reactants. Not only first order reactions, next coming second, third also, that depends upon the concentration of the reactants. Okay, so first order reactions, they depends upon concentration of the reactants. Okay, for example, if we take a reaction, first order reaction, A gives products. And rate for this reaction R is equal to K into A to the power 1. So, order of this reaction is 1. Okay? So, here rate depends upon concentration of reactants to the power 1. So, order, we consider order for this reaction is 1. Then coming to some examples of first order reaction. Next, some examples for first order reactions. So, decomposition of N2O5. So, N2O5 decomposition into N2O4 and oxygen. Then, decomposition of SO2Cl2. SO2Cl2 decomposition into SO2 sulfur dioxide and chlorine. Then decomposition of hydrogen peroxide H2O2 decomposes into H2O and half wood. Okay. Then disintegration of radioactive elements. All disintegration, radioactive disintegration reactions are also first order reactions. So radioactive disintegration reactions, they comes under first order reactions. Next, ester hydrolysis reaction. So, ester, ethyl acetate, this is ester. It undergoes hydrolysis in presence of acid, few drops of sulfuric acid. Here we get acetic acid along with alcohol. So this is also first order reaction. Okay. Then some gaseous first order reactions. For example, hydrogenation of ethene. Ethene into ethane. Hydrogenation of ethene into ethane. Ethene is ethylene. Ethylene undergoes hydrogenation and forms ethane. So, gaseous first order reaction. So, that is hydrogenation of ethene or ethylene into ethane. Ethene into ethane. So, here hydrolysis of ester, this is also called as pseudo first order reaction. Pseudo first order reaction. So, name of this is pseudo first order reaction. Why? Because here two reactants are there. Okay. But here water is present in excess. That's why we neglect the concentration of H2O here. Okay. And we take the concentration of ester only. So, that's why this is pseudo first order reaction. And one more pseudo first order reaction is inversion of sugar. Sucrose undergoes hydrolysis. Pseudo first order reaction. One more pseudo first order reaction. Okay, sucrose undergoes hydrolysis. Okay, here it forms 1 mole of glucose and 1 mole of fructose. So, sucrose on hydrolysis. Okay. So, here 2 reactants are there. But here water is present in excess. That's why we neglect the concentration of water here. And this is first order reaction. Why? Because we consider the concentration of sucrose only. So, this is also first order reaction, which is called pseudo first order reaction. So, both hydrolysis of ester and inversion of sucrose, inversion of sugars, which is also called as hydrolysis of sugar. Okay. So, both are pseudo first order reactions. Okay. Next, coming to second order reactions. Second order reactions. So, 2 types of second order reactions are there. For example, 2A gives products. So, here also A to the power 2, order is 2. Okay. And A plus B gives products. So, this is also second order. Okay. A to the power 1, B to the power 1. Sum is 1 plus 1. So, this is also second order reaction. So, for this type of reactions, reaction depends upon the concentration of reactants. In case of second order also. Some examples of second order reaction. So, next examples for second order reaction. Decomposition of N2O. So, into nitrogen and oxygen. Decomposition of Cl2O, chlorine monoxide. Okay. So, into 2Cl2 plus O2. Okay. And here nitrous oxide N2O decomposed into nitrogen and oxygen. Chlorine monoxide decomposes into chlorine and oxygen. Then alkaline hydrolysis of ester. CS3COO C2H5. This is also an example for second order reaction. Here we are using alkali. Whereas in first order reaction, hydrolysis of ester is pseudo first order reaction where we use water there in excess. So water is excess, that's why we neglect the concentration there. Okay. So that's why that belongs to first order. But here second order reaction, we consider the order of sodium hydroxide also, concentration of sodium hydroxide also. That's why order is 2 here. Next, nitrogen dioxide. Okay, decomposition. This is also second order reaction. Next, third order reactions. So, third order reactions, 3 ways are there, 3 types. 3A gives products. This is first kind. 2A plus B. This is second kind. A plus B plus C. Okay, this is third kind. So, nitric oxide oxidation into nitrogen dioxide. So, this is third order reaction. And nitric oxide with the chlorine forms nitrosyl chloride. This is also third order reaction. Then coming to fractional order reaction. Okay. So, reaction between hydrogen and bromine. But according to reaction here, 1 mole of hydrogen and 1 mole of bromine is there. But its order is 1.5. So, you know that order is experimentally proven equation. So, experimentally proven order for hydrogen is 1. With respect to hydrogen is 1. And bromine is half. Sum of powers. So, 1 plus half. So, 1.5. Same thing with the COCl2 preparation. Okay, was in carbonyl chloride. CO with chlorine forms COCl2. Carbonyl chloride. Here order with respect to CO is 2 and chlorine is half and total order is 2.5. Then negative order reactions, conversion of ozone into oxygen. So here order with respect to oxygen is -1. So this is negative order reaction.